Electrochemistry. We'll start. What is electrochemistry, by the way? Electrolytic cell and electrochemical cell. There are two types of cell. Electrolytic cell means we are giving the electricity, and out of that we are producing some new material. That is the electrolysis, electrolytic cell. And electrochemical cell, we are producing electricity. Our target is to get the electricity out of some chemical reaction, like battery.
Like cells, sir.
Yes, battery, cell, whatever you say. What is cell and battery difference? Usually, cell means this is a single unit, and battery means multiple unit combined together. Maybe looking single, but in fact there are a lot of other things together. For example, you take some inverter battery. There we have lot of plates, cathode, anode, multiple number of cathodes and anodes together. This is a battery.
And the small batteries are
Small battery normally one cathode, one anode, and multiple number. Yeah. So you have a example of a battery, small. We are calling it battery, but actually it's a cell, like torchlight battery. So there, what we are using, there is a container outside, there is zinc container, and inside there is a rod. The rod is graphite, and the top of the graphite rod there is a copper cap, and inside there is some solution, some sort of moist material, not solution actually, solid, but solid, and it is a moist solid, like ammonium chloride, that type of compound is there. Okay, so that is a cell. So sometimes we need more number of cells to combine together to run the machineries. So then again it's a battery, because combination of cell is a battery.
But the outermost layer, as you can say, that is
Zinc.
made by the zinc.
Zinc.
But usually it is made by the tin.
No, actually zinc, and it may be covered by some other material. So zinc is a very good one, because what is the? Can anyone tell me what is a basic, that very common, popular electrochemical cell? What is it is called? What is the name of that? Lakeland cell, most popular one. As an example, what you can take? As example, in any book you open, you get an example of electrochemical cell. What is that? Ki naam hai? Daniel cell. Have you heard about Daniel cell? And what is the basic components in that? In the Daniel cell, what are the components? Zinc and copper. Zinc copper couple. So our battery, there is also zinc copper couple. So in the top, I told now there is a cap. Achha, the whole thing, if you take copper, it will be very costly. So rather, copper is a very good conductor of electricity. That's why you are using a small amount of copper, but giving the same purpose. Why? Because actually we are going to throw it out after some time. So we are not supposed to invest a lot of money into that. So that's why we are taking a rod, and on that graphite rod, and the top we are giving some copper cap. But you are getting copper, very good contact. Copper is giving very good contact. That's why you are taking copper. Copper wire is the best for carrying the electricity, for wiring. Copper is the best. Earlier days, for cheaper material, we used to use aluminium also. But aluminium, for over a long period of time, it gets rusted. This rust is something different. It is aluminium oxide. So white powdery like material is there on the surface. So contact goes down after, say, a few years, maybe 10, 15 years or 20 years. After that, you will find the contact is not good for aluminium. But copper is not like that. Copper can be replaceable, and you can repair the thing very nicely. Easily you can repair. But aluminium, once the wiring is gone, you will change the whole wiring. Cannot do much of thing. Means repairing not possible. You will have to replace. Becoming costly. Okay. So earlier days people used to use aluminium. Because of money, cost, nothing else. Aluminium is cheaper compared to copper. But if you use copper wire, it will be long lasting. So, electrochemistry is the study of chemical reactions that produce electrical effect and the chemical phenomena that are caused by the action of currents or voltages. So that is electrochemistry. Actually, electrochemistry contains both the thing, electrolytic component, materials, and electrolytic cell as well as electrochemical cell. Electrolytic cell, they are doing the electrolysis to produce some material, manufacturing, Kastner process, Kellner process, preparation of sodium, okay, preparation of sodium, chlorine, these type of things if we need, then this method we are using is called electrolytic cell. An electrochemical cell is actually battery producing current, producing electricity. Portability. You have current everywhere, but can you use it into car? Can you use it into a torchlight? Not possible. That's why you have to have some portable unit. That is the electrochemical cell. Cell is the small unit, and battery combination of cells usually. So that can be a total into a container also, like our inverter battery. There are already told you. Okay, so I should not repeat. So here, this battery, there is a positive terminal and negative terminal, and in between multiple number of plates. Cathodes and anodes are there in large number. Though the more the number of plates, you get more and more voltage for higher voltage. And if you increase the size of the plate, please listen carefully this point. If you increase the size of the plate, in that case your capacity will increase. Means it will be long lasting. It will give you more power for longer period of time, not the voltage. But if you increase the number of plates, then it will increase the voltage. Get the difference. One battery 1.5 volt, two battery 3 volt, four battery 6 volt. That way you are using, huh? Then you are getting what? More and more number of?
Voltage.
Yeah, it is enhancing the voltage. But size of the battery, it will give more capacity. Small battery, how much time it will last? How much longer it will run? Small time. Big battery, it will run for a longer time, longer period. That means longer period depends on size. If you have bigger size, it will last longer. Okay. Practical example. You have power failure. You are using inverter. You have a small battery. It will run for 2 hours. You have a big battery. It will run for 8 hours. But the voltage, same. You cannot increase the voltage. Your all electricity appliances will be gone if you increase the voltage, right? So cannot increase the voltage. Voltage will have to be fixed. How much is the voltage? Battery? Our inverter battery, what is the voltage? No idea. No, more than 110. 110, 120, 130, it will be like that. And what is our power voltage? 220.
220.
No, fixed, 220. Our 220 to 240 in that range. Our here, this electricity. And battery, it is 110, 120, 130 is varying like that. So that I have seen there is a switch. If you press, you can see the output voltage. Okay, in the inverter, there is a switch. If you press, you can find the output voltage. Okay, so then question is,
The voltage is 120.
120. But the question is, yes, it runs. Nowadays our
Power will decrease now.
no. Your light will be a bit dim, but it will run. So nowadays the appliances are made in such a way it can run by this voltage. Our particularly LED, even fan, they are running, no problem, because they are making that way. They know that there can be power failure and people are going to use battery. So accordingly they are making so that it can be more marketable. If you are making in such a way that it is only running by electricity and not by battery, then who will buy that? So practically you cannot. So it depends on your this particular machine, the inverter machine, not the battery. So what will happen? That the inverter battery, it can make the electricity step up and step down. If it goes giving higher voltage, then capacity will go down. So that's why it is moderating the electricity flow so that it can run much longer. Sometimes what happens, it can run overnight. Very long time it can last. Okay, but you have to maintain the battery also accordingly. You have to add water and all these things. Okay. So redox reactions based. Why redox reaction? Because this battery, what we are going to study, it is based on this redox reaction, oxidation reduction reaction. Otherwise, how the battery will run? See, galvanic cell as example. What you have? Zinc and copper. Now zinc is getting oxidized at a Zn2 plus, and copper ion is getting reduced as Cu. Cu2 plus 2 equal to Cu. That is happening at the cathode, and at the anode, Zn giving you Zn2 plus 2e. So that is galvanic cell. That is a good example of electrochemical cell also. Achha. Now, this electrochemical cell, there is also another name called Lakeland cell. Electrochemical cell or Lakeland cell, and this galvanic cell. And this Daniel cell is a specific example. Specific example. Zinc and copper, if you use, then it is Daniel cell. Otherwise, it is electrochemical cell. May not be Daniel cell. So Daniel cell is also electrochemical cell. Example.
So in galvanic cell.
Galvanic cell.
Zinc and copper.
Galvanic cell is actually zinc and copper, but it is electrochemical, used in a different way, opposite way it is used. Achha, now loss of electron is oxidation, gain of electron is reduction, and oxidizing agent is oxidizing others, reducing itself, reducing agent, reducing others, and getting oxidized itself. These are the basic ideas. Example, Fe3 plus V2 plus giving you Fe2 plus V3 plus. This is getting reduced and this is getting oxidized. So here in this case, Fe3 plus acting as an oxidizing agent, itself getting reduced, whereas V2 plus is itself getting oxidized, so it is acting as a reducing agent. So at the same time, oxidation and reduction take place, not separately. Here in a single reaction, if you analyze, oxidation as well as reduction, both are taking place together. You cannot have one oxidation reaction, you cannot have a reduction reaction separately, both are happening together here. Otherwise, if there are only oxidation or only reduction if you do, it cannot be a cell. Cell means there will be complete circuit, there are two parts, one oxidation part, another reduction part. There can be separately made two chambers, oxidation chamber, reduction chamber, connected by some tube, which is inverted U tube, and there is some solution there inside. It's called agar-agar gel, and this material is called salt bridge. This salt bridge is made of an inverted U tube filled by agar-agar gel, and that is also contaminated with KCl or KNO3. Why KCl or KNO3? Why KCl or KNO3? K plus and NO3 minus, mobility is more or less equal, and that's why same amount of current is flown. Okay. Otherwise, what will be the problem if the velocity of this ions, cation and anion, are different? The problem will be that there will be some sort of resisting potential generated. Some opposite voltage will be generated in the opposite direction. Okay. Some resistance will be generated, because you see current. Hey, listen. One cation is going to the cathode and getting discharged. By that time, anode could not reach the anode. And as a result, the anodic discharge is not occurring. Then, after that, the potential in the opposite direction will be generated, because charge is imbalanced. So, in the opposite direction, the resistance is generated. And yes, and that is happening at the junction. So it is called junction potential. Junction means contact, where the rod we are immersing in the solution. These two rods are called electrodes. Okay, cathode and anode. These two electrodes. These are metals. These electrodes are metals like copper, zinc, metal. So what is happening? Suppose some cation is getting discharged, hydrogen ion is getting discharged at the cathode, but by that time the anion could not reach. Then what will happen? There will be some opposite potential generated, and on the surface of the this cathode, where H plus is getting deposited, means getting discharged and producing hydrogen gas. So after that, maybe a few ion H get discharged, and after that what will happen? Then no further H plus can be discharged, because resistance is growing. So in that case, you have to apply maybe more current, more voltage to forcefully discharge. Yes, that is called over voltage. So these things are there, and as a result, okay, let's take example one by one. So voltaic cell. So here electricity is generated, and there is a meter called voltmeter. It is measuring the potential difference, and you have both sides two electrode. Here it is zinc and here is H plus. So this is galvanic cell or voltaic cell. What is the purpose here? So someone was telling now that galvanic cell is zinc copper Not always. See, zinc and hydrogen also, this is galvanic cell or voltaic cell. Zinc and hydrogen
But the
are
Daniel
not,
cell is
not,
fixed, zinc and copper.
that is Daniel cell, yes, fixed. So here voltaic cell means there is some current is produced, that is voltaic cell. This is not specifically zinc and copper. It can be other electrode also. See here, zinc and hydrogen is taken as the electrode. So how hydrogen can be electrode? It is called standard hydrogen electrode. Standard SHE, standard hydrogen electrode. What is that? In that you will have a solution of acid like HCl, 1 molar solution maybe, and then hydrogen gas is bubbling through that liquid. So as a result, what is the equilibrium generated? That is H plus H2. The equilibrium generated is H plus H2. So this equilibrium H plus H2, we are considering the voltage is 0. Why? Please listen carefully, don't talk. Listen, every word is important. Listen. So when you see that electrochemical series, you have seen electrochemical series, you know activity series, these things are quite old, isn't it? In the class, school level you have learned that what is electrochemical series, there are activity series. Can you tell me the difference between electrochemical series and activity series? Yes, there are two series. One is called electrochemical series, other one is called activity series. Electrochemical series, basically, it is based on solution, an aqueous solution. Okay, solution is aqueous solution, and based on aqueous solution, the potential generated, we are making a list, a chart. That is called electrochemical cell. Some will be below hydrogen, some will be above hydrogen. So that why you are talking about hydrogen? That is the standard. Above hydrogen and below hydrogen. So there is somewhere in the middle will be hydrogen. So that is taken as the reference frame. Got it? Hydrogen is the reference frame. So normally reference is always 0. So that's why hydrogen potential we are considering 0 potential. So hydrogen in equilibrium, whenever achieved, we make it a 0 potential. We consider it 0 because we are making a chart. So some will be some positive value, some will have some negative value. So someone has to be 0 value, that is hydrogen. So some are above hydrogen, some are below hydrogen. Those who are above hydrogen, they are having some potential to get reduced. Like this, okay. Suppose sodium, positions of sodium above hydrogen, iron above hydrogen, zinc above hydrogen. So they are always getting oxidized easily. So Zn to Zn2 plus 2e, Na giving Na plus E, potassium gives K plus E, quite obvious. Some are below hydrogen, those who are getting discharged easily, like Cu2 plus 2e equal to Cu. Achha. Lead, copper, silver, gold, they are all below hydrogen. Lead, copper, silver, gold, they are below hydrogen. Above hydrogen, Na plus, Na, sorry, not Na plus, Na, K, Zn, Fe, they are above hydrogen. Why? According to their nature. Why you are placing them above and below? I am giving a small experiment. It's a small, from the experiment you will understand. We have all the ions present, theoretically. Practically also you can do it. We make a solution mixture of all possible ions, cation, anion, all present together. Now, we are giving 2 electrodes. Both are inert electrode, let it be platinum. Very inert electrode, that is platinum. Now we are slowly giving the current and increasing the voltage from very low. Suppose 0. From 0 you are increasing the voltage. Follow the discharges. Follow the discharges. Which one will discharge first? Those who are all cation present, okay. Those who are below hydrogen, they will be discharged first. But low means how much low? You have to get the values that you get from this experiment. You are increasing the voltage slowly. One by one is discharge is getting started. You found that lead is discharged already. Then after that copper is getting discharged. So from that you get the values also. Not only the idea, you are getting values, exact values. That is the EMF. Which particular EMF the discharge is happening. Accordingly making the chart, that is called electrochemical series. See, without experiment, how can you make comment this is below hydrogen, this is above hydrogen. You have to first make experiment, get the EMF chart, and that is standardized, it is available. That's why you are making comment on that. So first of all, mankind has to make this. So it is this way. You have all ions present and you will be improving or increasing voltage one by one. Slowly you are increasing the voltage and one by one discharge is started, and you can note down at what voltage which particular ion is getting discharged. And you have to take concentration of all equal, flat rate. Otherwise you cannot compare. You have to take all concentration of all the ions equal, more or less equal, maybe molar, all are molar. So in that case, you just find out which one is discharged first and what value, note down. Then discharge second one, note down. That way, it will increase more and more voltage. In fact, hydrogen is getting discharged. After that, maybe iron is getting discharged, and after that, your others, zinc is getting discharged. Zinc is high above the hydrogen also. So
Aluminum is also above.
the least I cannot more or less have idea. Exact value is difficult to say. And after that, you have sodium at the top. Sodium, potassium, they are at the top, because they always want to become cation. They are highly electropositive metal, that's why. Alkali metals, so they are at the top. So alkaline earth metal should be below that. And as you go in the, we have idea, periodic table, from left to right if you go, accordingly it will happen here also. And top to bottom if you go, the metallic character is increasing, and accordingly the discharge will take place. So it is a same thing you are learning like periodic table, but in a different way. What is the basic difference between periodic table, your chart, and your this electrochemistry chart? Here you are taking aqueous solution. Some property may change, because apart from this what is this called? When electron is removed from the cation, how energy is given, what is that called? Ionization potential, right? So ionization potential, based on ionization potential only, it is not happening. This electrochemistry, this phenomena happening based on two parameters. One is the ionization potential plus another parameter, that is hydration energy. Because we are taking aqueous solution, so hydration energy. That's why two parameters are interlinked here. So always this only one parameter may not be sufficient enough. Like copper and copper plus, copper 2 plus. Theoretically, copper plus should be more stable, but practically found copper 2 plus is more stable. Why? Because another factor is coming which we have not considered yet, that is hydration energy. So Cu2 plus hydration energy is much higher compared to that of Cu plus. Okay? Because the more the charge of the cation, more will be the hydration energy. Water molecule will surround that in a much better fashion. More number of water molecules will surround it, the cation. So hydration energy will be more. So the higher charge cations are getting hydrated more compared to lower charge cation. So copper ion and copper 2 plus ion, Cu plus, Cu2 plus, if you compare, theoretically Cu plus should be more stable, because it is, what is the electronic configuration? Cu plus 4s0 3d10. Isn't it a complete cell? Supposed to be more stable. 4s0 3d10 supposed to be more stable, but practically found fully filled, but practically what found? Cu2 plus is more stable, because we are getting maximum abundant different compounds, Cu2 plus compound. Then how can we explain that? First phenomena, then explanation comes. How can we explain that? That can be explained with the help of this hydration energy phenomena. So this electrochemistry chemistry lab, so that is the thing. Let's go ahead. Achha, by the way, here I was talking about this hydrogen ion. Their discharge is taking place. H plus plus E giving half H2. H plus plus E giving half H2. So 2H plus plus 2E equal to H2. That I am talking about. So here the potential will be considered 0, because it is in the middle. Above that, all are cationic character, more higher cationic character, more electropositive nature. Below that, less electropositive nature. Okay. So below hydrogen, above hydrogen. Those who are below hydrogen, they cannot produce hydrogen gas from the acid. Those metals cannot produce hydrogen gas from acid. Like copper, if you put into acid, it will not produce hydrogen. Right? Those who are electropositive element, like zinc, if you put into acid, it will produce hydrogen. So from that we got the idea at the beginning that above hydrogen, below hydrogen idea, which can displace hydrogen, that is above hydrogen, which cannot be displaced hydrogen, then it will be placed below. Okay. So
And what about the equivalent or activation?
activity series, yes. Activity series entirely based on one factor, that is ionization potential value. IP, yeah, ionization potential values. It is based on one parameter, and electrochemical series based on another two parameters. That's why there can be some slight difference. I can give you one example: calcium and sodium, Ca and Na. Activity series and electrochemical series. You find the difference in position. Sodium, calcium, if you compare activity series and electrochemical series, you find the difference in position. This is happening because of second factor, that is hydration energy. Which one is giving more hydration energy? Tell me. Calcium or sodium? Calcium, because already I told you it is plus 2 charge. Higher charge means better hydration energy. So it is giving more stability, and accordingly its position will be different.
So
Hydration energy means it is the energy released when 1 mole of cation is dissolved into some solvent, some water as a solvent. And if you take any other solvent, then it is called solvation energy. And if you take water as a solvent, then hydration energy. These two factors. So activity series based on only ionization potential values, and electrochemical series based on these two parameters, this potential energy, obviously ionization potential value, and also the hydration energy.
So why the energy series? Why the energy release?
When cation is dissolved, okay, because the
bond?
cation, no bond, it is ion dipole interaction, because of ion dipole interaction. Is it clear? Sodium ion surrounded by water molecule. Water has got two poles, plus side and minus side. Sodium ion is a positive charge cation surrounded by water, so water negative part will be attracted towards the positive cation. So cation and the dipole interaction. So it's called ion dipole interaction. And this ion dipole interaction is more for cation compared to anion. There will be for anion also, but it will be lesser. Why? Because anion is larger in size usually, cation becomes smaller in size. That is the reason. Size matters. If it is small size, it is giving more hydration energy. If it is larger size, it will give less hydration energy. That's why Cu2 plus is giving more hydration energy compared to Cu plus, because it is smaller. Ca2 plus and Na plus. C2 plus is smaller. That's why hydration energy is more. By the way, one more thing. So what is the importance of this? This is 0. So from here, the actual potential developed by the zinc can be can be calculated. Why? Because until and unless complete circuit is there, you cannot measure the potential. Circuit must be completed, otherwise there will be no current flow. And if there is no current flow, how you can use your instrument? Ampere meter, voltmeter, everything will run only when the current flows. It is a stagnant electricity. You cannot measure it. For measuring, current must flow. That's why you have to complete the circuit. Or for completing the circuit, zinc and hydrogen, and if we take, this is considered as zero potential. So the potential of this will be the total potential. So potential of the cell will be equal to the potential of this plus potential of this. But this is 0. So you get this. So that is the advantage of reference electrode. That is the reference electrode. This is reference electrode. Standard hydrogen electrode is the reference electrode. Based on that, you are getting the potential for zinc, potential for copper. Individually, you can find out. Okay. For copper, maybe direction of current will flow, but you get some values now. So that values will be below that hydrogen. That will be placed below hydrogen. So we have a chart. You can get the file in time. So here, this is the reaction.
So below the hydrogen it comes in minus?
No, opposite direction. One is normally, just a minute. You are measuring what? You can measure two ways. Either you are measuring reduction potential or you are measuring oxidation potential, depending on which reaction you are following. Zinc is giving Zn2 plus 2E. That reaction, if you take, then is the oxidation potential. And Cu2 plus 2E equal to copper, if you consider, there is a reduction potential. But you cannot take both, now it will be confusing. That's why normally that reduction potential is considered. Reduction potential.
Oxidation.
No, anyone can be actually, anyone, but not both together. Into a chart, there can be one parameter only, either oxidation potential or reduction potential. But reduction potential is a usually it is usually given into everywhere, means as a voltage. I show you here. This is that it is written. See, it is written. Reduction potential 0.76 volt. For whom? For whom? Zn to Zn2 plus, just a minute, I will clarify the matter. Zn to Zn2 plus, oxidation, that is spontaneous. That is spontaneous, that is his natural tendency. Zn becoming Zn2 plus, that is natural tendency. So that's why this will be called oxidation potential. That plus 0.76 volt, that is the oxidation potential. If you take the reduction potential, it will be minus 0.76 volt. So it doesn't matter which one you take. But normally reduction potential values are given everywhere. But it will be written normally. Say like it is written here, standard reduction potential, only value given. That you have to understand. Reduction potential, it will be here negative. For zinc, it will be negative. But oxidation potential, positive. So here it is written positive, see, no symbol is given. But clearly mentioned reduction potential. So there is no confusion. If it is, you are considering oxidation, it will be plus 0.76 volt. If you are considering reduction, then minus 0.76 volt. This is the chart. Have a look. See, it is negative. Reduction potential, that's why negative. We told now that it will be oxidation. No, you see, it is reduction potential. Standard is reduction potential. Custom, there is no scientific reason. One you have to stick to one. Both are valid, both are right, but you stick to one. So, oxidation potential power increases, reduction potential increases. Oxidation potential downward increases, but reduction potential upward increases. These are all reducing metal. If you just look at here, you will understand. These are all reducing metal. Apart from hydrogen. Hydrogen also reducing, though not metal, but is also reducing. And below that, they are all what? Oxidation. Because they are themselves getting reduced. So they want to get oxidize the others. So it's the same thing. This side and this side, if you compare, you will understand. Ag plus plus 2e. Ag plus is oxidizing agent, but Ag is reducing agent. Na is reducing agent. Na plus is oxidizing. Isn't it true? So that's why it is given, the chart is given like this. Li plus plus E. Here it is accepting electrons, so it is oxidizing agent. Li plus is oxidizing agent. But Li as a metal, if you use, it will be reducing agent. Actually, the same thing you are telling in two different languages, nothing else. And the values. How many values do you remember? Not possible, na? Acha, remember only two, please. One is zinc and this is copper. Acha, if you take copper 2 plus plus 2 equal to copper, I remember that value actually. 0.34 volt. And zinc minus 0.76 here. Reducing potential minus 0.76. So oxidation potential will be plus 0.76. Now what is the total EMF of zinc copper? If I take one zinc and one copper half cell, Zn to Zn2 plus, that compartment is half cell, that is the anodic compartment. And copper and cathodic compartment. This anodic compartment and cathodic compartment, if you combine by some salt bridge connection and wire connection. Electrode to electrode wire connection, solution to solution, salt bridge connection. Just like here. The salt bridge is there here. So if you connect that way, then how much potential will be developed? As an example I am telling you, Zn to Zn2 plus is giving plus 0.76 and copper plus plus 2e giving plus 0.34. But in anode, zinc anode, oxidation is taking place, and in the copper cathode, reduction is taking place. So as it is, if we take the values, total potential developed will be 0.76 plus 0.34, which is 1.1 volt. Just one second. We are taking one. Anode is kept at the left side and cathode is always kept at the right side. That is custom. So here Zn and here copper. Now Zn is giving Zn2 plus 2E, and either here is EMF is Zn2 plus EMF equal to 0.76 volt, and Cu2 plus 2E copper. So E cell, E anode plus E cathode equal to 0.76 plus 0.34 equal to 1.1. That I was telling.
माइनस 0.76 की वैल्यू
माइनस नहीं होगा क्योंकि मेरा ऑक्सीडेशन लिया मैंने. जिसको रिडक्शन लेंगे तो माइनस होगा. इधर ऑक्सीडेशन होता है, दोनों में तो रिडक्शन नहीं होगा ना. एक में ऑक्सीडेशन होगा, दूसरा में रिडक्शन होगा. तो इसको ऑक्सीडेशन होने दो. एनोड में तो ऑक्सीडेशन ही होता है ना. एनोड में तो ऑक्सीडेशन ही होता है. तो उसको जो जिधर जैसा है उसको ऐसे ही रखा. मतलब जहाँ ऑक्सीडेशन उसको ऑक्सीडेशन पोटेंशियल लिया, और जिधर रिडक्शन होता है उधर रिडक्शन पोटेंशियल लिया. दैट इज क्वाइट ऑब्वियस ना. एक में ऑक्सीडेशन होगा, दूसरे में रिडक्शन होगा. दोनों में तो रिडक्शन नहीं हो सकता. वी हैव टू कंसीडर वन एनोड वन कैथोड. So one anode is zinc. So Zn2 plus Zn is forming Zn2 plus 2E. That is actually its reaction, and I'm not changing that I'm doing. So whatever is happening accordingly I have taken. So Zn is giving Zn2 plus 2E, and the potential developed is 0.76 volt, whereas Cu2 plus 2E equal to copper 0.34 volt, and there it is reduction potential. So in one case I have taken oxidation potential, in another case I have taken reduction potential. Why? Because actually that is happening. So why do I change it? I am not changing. And that is the best one, I think. By this type of sign convention and sometimes this, sometimes that, it is better. What is happening, follow that. Accordingly you take the values. There will be no confusion. In anode, let it be oxidation and take the values accordingly. And in cathode, there will be reduction, take the values accordingly and then add up. You get the potential. So E cell equal to E anode plus E cathode. E anode was 0.76. By the way, one thing, I have taken this thing in all standard states. Otherwise it will be a bit more complicated, not so simple. Here I have taken all in standard states. That's why I can use a symbol here 0, 0, 0. 0 means standard state. Not always. This is the symbol. 0 symbol used means it is at the standard state. It's a line notation. Let's have an idea. Could you get the value things whatever I discussed so far? Any question from anyone? Any doubt? No. Okay. So line notation. Line notation is very simple. Whenever you have a metal and a liquid, what we are doing? Taking one metal and immersing in the solution. That is our half cell. So metal and liquid, there will be some contact that is represented by a single line. Solid aqueous. Solid versus aqueous. Solid means electrode and aqueous means solution. So solid and aqueous, in between there is a single line representing the interface. Solid liquid interface. Then after that there is a double line representing the salt bridge. Solution to solution contact. Then again solution which is there in the cathodic compartment. Aqueous solution in the cathodic compartment, and there is a single line representing that surface interaction between the solution and the solid. So this is the representation. Solid.
The interaction part there should be a voltage drop.
Maybe. That's why it is this line is given. It is the interface. There can be some junction potential generated. Maybe. It may happen. It happens. Acha, one idea I am giving, some practical idea. Practical is very important. Okay, without practical, your theory will not be completed. You have taken, suppose, some potential I was talking about. If you take zinc sulfate solution and dip some zinc metal rod into that, can you tell me how the potential is developed? It is called Helmholtz double layer concept. Helmholtz double layer concept. You have heard about Helmholtz? Gives Helmholtz equation. That Helmholtz. Helmholtz is a big scientist, famous scientist. Now I am talking about that. If you, it is called Helmholtz double layer. You are taking a solution, zinc sulfate or zinc chloride, whatever, and there the zinc metal is rod is dipped. What will happen? Nothing should happen, because just solution and metal. Okay, but something is happening. What is that? Some more zinc metal from the surface of the rod will dissolve in the solution, producing Zn plus 2 plus 2e. Zn2 plus 2e. Huh? No, dissolve. It is getting dissolved. A few molecule, not a huge number. A few number of molecule will dissolve, and after that, when it dissolve, carefully listen. When it dissolve, then what will happen? Some of the electrons will be left behind in the metal surface itself. Because when the zinc metal is getting dissolved in the solution, where the electron will go? Zinc is going as Zn2 plus, not as zinc. Whenever it is dissolved, it is producing Zn2 plus, and the electrons is remaining behind on the surface of the zinc rod itself. So zinc rod is becoming negatively charged. So further dissolution is prevented by that. 2-4 डिजोल्व होने के बाद और नहीं हो पाएगा, क्योंकि इसमें पोटेंशियल नेगेटिव चार्ज बन गया. So further releasing of electron will be very difficult there, because there is electron repulsion. Got it? That's why there is some surface potential generated there, and that is the reason of this oxidation potential, reduction potential. Why potential is generated? I am going to the root cause. Try to understand the root cause. Why does it happen? জিঙ্ক রড এখানে দেখা যাবে তো?
হ্যাঁ স্যার।
না, এদের কথা ভাবছি। নাও দিস ইজ জিঙ্ক, নিচে দেখা যাবে। সো Zn is giving you Zn2 plus 2. ঠিক? তো what will happen after a few such reaction? Here negative charge will be developed on the surface. Naturally, because electron, where it will go? Electron cannot go into the solution. Why cannot go? No stability. How electron has got any stability in the aqueous solution? It is cannot be solvated also, and anything not solvated cannot go in the solution. So electron will be remaining on the metal plate itself. Metal को ऊपर है, right?
वो तो स्टेबल रहेगा सर।
हाँ, तो metal उसको it can hold. Metal electron को hold कर सकते हैं. नहीं तो करंट कैसे फ्लो हो रहा है? मेटल से जा रहा है. ऑल द वायरिंग
उधर तो आउटर मोस्ट पे नहीं रहता ना, अंदर रहता है।
नहीं वो सो फ्री इलेक्ट्रॉन्स, सम फ्री इलेक्ट्रॉन्स, नॉट बाउंड. अच्छा, नाउ another thing, the water molecules, they are represented as dipoles, right? So you have got positive and negative side of the water molecules called dipoles. So it will be attracted because of this negative charge. It will be attracted.
H plus है।
So you will have, no, not because of ion, because of this thing. Water molecule is represented as dipole. No, it is not producing H plus, because the water is a neutral, it is not acid. So it will produce this type of, but this positive side of the water molecule will be attracted towards this. So as a result, some potential is there on the surface. This surface of the surface potential is developed, and towards the bulk also potential is expanded. So but it will fall. Potential will fall. Some surface potential is generated, and that is the root cause of the potential difference, the current, everything. Static electricity first, and current will flow later. First the static electricity is generated, na? Then only. Acha, now if this is the case for zinc-zincan, then what about the copper-copper ion? The opposite thing will happen. So in the metal surface, 2 plus will be generated. Time is almost over, so I will complete this now. So this copper, what is will happen? There is a negative on the surface of metal. There will be plus plus plus, and on the nearby there will be minus minus. So there is a again a double layer. Here there is a double layer, plus and minus side by side within a few micrometer gap. So in the copper and also same thing. So that is called,
There should be a voltage difference.
and this is called double layer formation. Okay, double layer formation, and it happens in cathodic compartment as well as anodic compartment.